For years, AI has basically been treated like this magic trick trapped inside a tiny glass box on your screen.
Right, yeah, like a party trick almost.
Exactly. You type a prompt, it performs a trick, and you marvel at the output. But today, that intelligence is breaking out of the box and quietly wiring itself into the actual operational nervous system of the enterprise.
It really is. It's everywhere now.
But before we dive into exactly how that is happening, this deep dive is brought to you by AI Opportune. If you are a founder or a business leader trying to navigate the absolute wild west of workplace technology right now, AI Opportune is your go-to resource.
Oh, absolutely essential stuff.
Yeah. Every week they deliver actionable AI implementation guides, real-world case studies, and strategic breakdowns. It is the blueprint you need to move from theory to execution, so I highly encourage you to subscribe to AI Opportune today.
Well, the transition you just mentioned, moving from that isolated text box to integrated enterprise systems, is really the defining technological shift of this decade. I mean, we are moving from conversational AI to autonomous agentic workflows.
So the mission for today is to explore that massive paradigm shift. For you, the listener out there, whether you are a leader desperately trying to scale a company without doubling your headcount, or just a professional exhausted by the administrative drag of manual data entry, this shift is fundamentally rewiring how work gets done.
It really is.
It's the difference between an AI acting as a very fast typewriter and an AI acting as an independent project manager.
Right. To understand the mechanics of that shift,
Yeah.
we have to look at how humans have, historically interacted with software.
Okay, let's unpack this.
Yeah,
Because we've always been the bridge, right?
exactly. We have always been the manual bridge. Even with the advanced chatbots of the past few years, the user is effectively a courier.
Yeah, carrying data back and forth.
Right. The system gives you raw material, but you still have to copy that text and carry it over to your email client, format it, open your CRM, update a record, and send a message.
You are managing every micro step. I like to think of traditional software and even early generative AI like a microwave.
A microwave.
Yeah, think about it. You have to punch in the exact time, manually open the door, put the food in, take it out, stir it, and if it's still cold, you have to punch the buttons again.
Right. You're orchestrating the entire process.
Exactly. Agentic AI operates more like a sous chef.
Wow.
It knows what ingredients are in your pantry. You give it a high-level goal, like make a beef bourguignon, and it autonomously breaks that goal down into subtasks.
Yeah, it figures out the steps on its own.
It preps the ingredients, manages the cooking times, adjusts the sheet if something is boiling over, and plates the meal.
And the underlying mechanism enabling that sous chef behavior is goal-driven reasoning.
Which is different from just predicting words.
Completely different. A traditional model predicts the next word in a sequence, but an agentic system uses the model as a reasoning engine to evaluate its current state, determine the logical next step, execute an action, and then evaluate the result of that action before moving on.
It's looping.
Right, it loops through this process independently.
Operationally, giving a system that level of independence eliminates massive bottlenecks.
Massive. Because what's fascinating here is that organizations adopting this architecture aren't just saving a few minutes.
They're changing the whole pipeline.
Yeah, they are cutting turnaround times from days to minutes, slashing costs, and completely eliminating manual data entry errors. When an AI agent can handle the handoffs, routing data from one department to another, or cross-referencing information across different legacy platforms, the administrative overhead simply vanishes.
But knowing that AI can act independently sounds great in theory.
Sure.
Orchestrating this inside a complex company without the system going completely rogue requires incredibly precise architecture.
Oh, absolutely. You cannot just plug a reasoning engine into your corporate network and tell it to optimize operations.
That would be a disaster.
A total disaster. Forward-thinking organizations build a highly structured, closed-loop pipeline.
Which starts where?
It always begins by isolating a specific business challenge, usually a high-friction point in the daily routine. From there, you move into the data collection and retrieval phase, which is where the system actually learns what is in the company's pantry, to use your analogy.
So let's break down how that retrieval actually works, because this is where the underlying tech gets really fascinating.
It does.
Companies aren't just uploading PDFs to a chatbot anymore. They're using vector databases and ARG architecture, which stands for Retrieval Augmented Generation.
Right. ROG setups are crucial here.
Instead of searching for exact keywords like a traditional database, a vector database turns your company's entire operational history into mathematical numbers or coordinates.
Yep.
It maps concepts by how closely related they are in space.
And that spatial mapping is critical for context.
How so?
Well, if the AI agent is tasked with handling a customer complaint about a refund, it doesn't just look for the exact word refund.
Right.
The vector database inherently understands that money back, return policy, and billing dispute all live in the exact same mathematical neighborhood.
Wow, so it pulls those highly relevant internal documents and feeds them to the language model.
Exactly. So the AI isn't hallucinating answers based on the open internet. It is formulating decisions constrained entirely by your specific company guidelines.
That's a huge distinction. So once we have that context retrieved, what happens next?
Once that context is retrieved, we hit the agentic automation phase.
Okay.
The agent analyzes the relevant data, plans the execution steps, and then triggers external software APIs to actually do the work.
Like pushing buttons in other apps.
Precisely. Let's look at how this transforms, say, B2B customer onboarding.
Oh, yeah, the B2B scenario. Enterprise clients often submit incredibly complex, dense security questionnaires and compliance contracts, right?
Very dense. And traditionally, an account manager spends days manually cross-referencing these documents against company policies.
Here's where it gets really interesting. Because under an agentic workflow, an extraction engine first parses the submitted text.
Right.
A specialized research agent then uses that RAG setup we just discussed to query the internal security policies and draft precise answers.
But the AI doesn't stop at drafting a document.
Right. It utilizes API triggers to actively push these tasks into a CRM platform like Salesforce.
Acts on it.
Yeah. The agent changes the deal stage, logs the compliance data, and assigns follow-up tasks.
The agent is actively orchestrating the workflow. It's acting as a project manager. But this brings us to the crucial safety net built into these systems, which is human oversight.
Right, because you can't just let it run entirely blind.
Exactly. When that AI agent encounters a high liability legal clause in the onboarding contract that deviates from standard policy, it is programmed not to guess.
It flags it.
Yes. The workflow routes that specific complex clause directly to the legal team for a targeted review. The result: the time it takes to onboard a new enterprise customer drops from 8 business days to under 3 hours.
Which is incredible, but I have to challenge the reality of that human oversight checkpoint for a second.
Sure, go ahead.
We hear a lot about keeping humans in the loop to prevent catastrophic errors. But if an AI is successfully handling 99% of these contracts flawlessly and reducing an 8-day process to 3 hours, the human reviewer is inevitably going to develop alert fatigue.
Oh, 100%.
Right. If a legal associate sees the AI get it right 500 times in a row, they're just going to start rubber stamping those flagged clauses without actually reading them.
Right, get complacent.
Yeah. And a single hallucination on a compliance contract could expose a company to millions in liability.
As is a very real vulnerability, and it is exactly why sophisticated deployments don't just rely on a generic flag for review button.
Okay, so how do they solve that?
The architecture combats alert fatigue through dynamic confidence thresholds and programmatic guardrails.
What does that look like in practice?
Well, the system isn't just saying, hey, look at this. If the AI's internal confidence score drops below, say, 98% on a specific clause, it highlights the exact conflicting vectors.
Oh, wow.
It presents the human with the new clause, the historical precedent it contradicts, and the mathematical variance. You force the human to engage with the anomaly rather than just clicking Approve All.
That makes the oversight active rather than passive.
Exactly.
The human isn't proofreading, they are arbitrating a specific highlighted conflict.
Furthermore, many organizations employ a multi-agent approach to cross-check work before a human ever even sees it.
Like having AIs check each other.
Right. You have one agent draft the response and a completely separate adversarial agent designed specifically to find legal flaws in that response.
That is wild.
Yeah. And if the two agents cannot reach consensus based on the company's policy vectors, only then is it escalated to the human.
So what does this all mean? That structural complexity is why this orchestration is getting incredibly specialized across different industries, isn't it?
Absolutely. We are moving way beyond generic administrative assistants writing emails.
I want to dive into a couple of the specific examples of how these connected models are embedded in highly regulated sectors right now.
Sure, there's so many.
Let's look at supply chain and logistics, specifically how platforms like SAP Joule are deploying agentic automation.
Logistics is a perfect environment for this because it involves massive volumes of structured data and high-stakes operational bottlenecks.
Right.
Imagine a scenario where a major storm delays a cargo ship carrying critical manufacturing components.
A nightmare scenario.
Right. In a traditional setup, a human logistics manager receives an alert, manually cross-references current inventory levels, realizes there will be a shortfall in 2 weeks, manually searches for alternative suppliers, drafts a new purchase order, and sends it for financial approval.
That process alone could take days, by which time the alternative supplier might be sold out.
Exactly. But with an agentic workflow, the system detects the delay via a weather or shipping API automatically.
It's just constantly monitoring.
Yes. The agent independently cross-references regional inventory levels across the entire enterprise. It calculates the financial impact of the delay, identifies the shortfall, locates an alternative supplier with available stock, drafts the purchase order, and queues it up for a single-click financial approval from a human supervisor.
So the AI is dynamically reacting to external world events and reconfiguring the company's internal supply chain in minutes.
In minutes, yeah.
That's crazy.
And in fields like healthcare operations, the data sensitivity requires an entirely different architectural approach.
I can imagine.
You have multi-agent setups, like those powered by FVC software, that are posting highly sensitive patient medical records.
Handling medical records introduces massive HIPAA and privacy concerns. You can't just pipe sensitive patient data into a public language model API.
Which is why these specific deployments utilize localized, fine-tuned domain models.
So they run locally.
Right. The reasoning engine operates within the hospital's secure, air-gapped network.
Okay, that makes sense.
One specialized agent parses the unstructured doctor's notes. A separate agent, completely siloed from the clinical data, takes the extracted procedural codes and verifies them against external insurance provider APIs to confirm coverage.
And they don't share the underlying patient data.
Exactly. And then a third agent interfaces with the hospital's scheduling software to book the follow-up.
Compartmentalizing those tasks limits the cascade of potential hallucinations and secures the data pipeline.
Yes, very strictly.
One agent isn't holding the entirety of the patient's identity and medical history while talking to an external insurance database. It passes only the necessary tokens forward.
That level of compartmentalization is central to safely scaling these systems. But deploying this architecture, whether for logistics, healthcare, or financial clearing, carries immense operational risk if done poorly.
Right, because you're connecting it to the actual business operations.
Exactly. Forward-thinking leaders employ a very strict phased playbook to build these unified architectures safely.
Well, the first rule of that playbook seems universally agreed upon by all the sources we looked at, which is start internal.
Yes, always.
You target high-volume, high-impact back-office tasks that operate on clear, objective rules. You absolutely do not start by building autonomous customer-facing agents.
Never start with the customer.
Right. You let the AI practice its reasoning engine on internal data syncing, where a mistake is caught by an employee rather than blasted out to your most important client.
Keeping the initial scope constrained is vital. And that leads directly to step 2, which is running focused 60-day to 90-day pilots.
Just to test the waters.
Right. But the objective of these pilots goes far beyond just checking if the AI gives the correct answer. You have to implement continuous telemetry.
Now, when we talk about telemetry in traditional software, we usually mean tracking server uptime or page load speeds. What does telemetry mean when we are monitoring an autonomous AI agent?
In an agentic workflow, telemetry is about monitoring logic drift and compute efficiency.
Compute efficiency.
Yeah, you have to track the exact reasoning path the AI took to arrive at a decision. If an agent makes 10,000 API calls an hour to cross-reference data, you need telemetry to monitor the compute costs.
Because those APIs aren't free.
Exactly. Every time that agent queries a foundational model to evaluate a step, it costs money.
Right.
An unoptimized agent running thousands of automated multi-step tasks can quietly bankrupt a project's budget if it's using a massive, expensive model for simple data extraction.
So you have to know if the 3 hours you saved on onboarding that client ended up costing you more in API compute power than the account manager's salary.
Exactly. It is an entirely new metric for ROI calculation.
The math has to work.
The math has to work. And the math only works if the system operates efficiently, Which brings us to the most critical, often overlooked step of the entire playbook.
Which is data structure and cleanliness.
Yes, data hygiene.
I look at internal data as the nervous system of an AI agent. If a company's internal data is disorganized, if their SharePoint is a chaotic maze of outdated PDFs, contradictory HR policies from 2018, and duplicate spreadsheets, their nervous system is basically corrupted.
It's broken.
When you plug an autonomous agent into that environment, it doesn't magically fix the mess. It weaponizes it.
That's a great way to put it.
The agent will pull conflicting vectors and initiate automated corporate spasms.
Right, because a reasoning engine can only reason based on the environment it operates within.
Garbage in, garbage out, but on steroids.
Exactly, on steroids. If you feed an agent contradictory operational data, it will confidently execute the wrong task at light speed. And it will use your APIs to distribute that mistake across your entire software stack.
Which is terrifying.
It is. Organizing internal document repositories, strictly mapping out data permissions, and standardizing APIs is mandatory before you ever introduce an agent.
You have to heal the nervous system before you give it a brain, which ties back into the governance aspect. Implementing strict permissions ensures the agent only has access to the data it absolutely needs for a specific task.
Right. You don't give it the keys to everything.
You safeguard proprietary information and build clear approval gates so you never lose control over critical business outcomes.
And if we connect this to the bigger picture, when you look at the organizations successfully navigating this playbook, you realize that the true competitive moat over the next decade is not going to belong to the company that purchases the most expensive AI model.
No. Who does it belong to?
It will belong to the early adopters who pair their unique, proprietary, and perfectly structured operational data with these specialized multi-agent systems.
Because they are going to operate at a velocity that is physically impossible for traditional companies to match.
Exactly.
Impossible.
The competitors who are still relying on employees to act as manual couriers, copying and pasting data from a chatbot text box into a spreadsheet, will simply be priced out of the market.
They won't be able to keep up. They will still be standing in front of the microwave while the early adopters have a fully automated kitchen staff running the restaurant.
The human role fundamentally shifts from being a manual laborer in the data mine to acting as the strategic supervisor of the data pipeline.
Right.
But looking at that shift structurally, it introduces a massive secondary challenge that isn't typically addressed in technical implementation guides.
What happens when the AI is doing all the foundational work?
Exactly. This raises an important question. If autonomous agents take over the routine approvals, the data syncing, the basic contract parsing, and all that manual busy work, how do organizations train the next generation of entry-level workers?
That is a phenomenal paradox. Because traditionally, learning the deep nuances of a business happens by grinding through those exact manual tasks.
Right, it's how you learn the ropes.
If a junior legal associate never has to manually review a grueling 8-day security questionnaire because the AI handles it in 3 hours, they might never fully understand the underlying legal rationale for why those specific compliance questions exist in the first place.
They skip the entire apprenticeship phase of knowledge work.
Yeah.
If the foundational mechanics of a business are completely abstracted away by autonomous agents, it becomes incredibly difficult for a junior employee to develop the deep institutional intuition required to eventually become the senior executive who sets the high-level strategy.
You lose the training ground. Leaders are going to have to entirely redesign career development and mentorship to compensate for the fact that the busy work was actually the classroom.
That's a huge challenge to tackle.
It is a brilliant, provocative thought to leave you with as you think about integrating these systems into your own operations. The transition from the isolated text box to the autonomous enterprise workflow is actively reshaping the mechanics of business.
It really is.
Thank you for joining us on this deep dive. And remember to turn these architectural concepts into actual execution and to get the case studies you need to build your own agentic workflows. Be sure to subscribe to AI Opportune today. It is your ultimate resource for staying ahead of this technological curve. Until next time, keep exploring.